All right, we're starting with Algebra 3's Unit 3, and we're going to talk about complex numbers and evaluating and simplifying radicals. As a review, when we have a radical, this is a square root. Underneath here is a perfect square because 16 can be multiplied by two numbers. And when you have a simple square, you just simplify it. The square root of 16 is 4, and when you simplify it, you're left with 4 without a radical, and it's plus or minus because positive 4 times itself is 16 and negative 4 times itself is also 16. When we have a negative underneath the radical, we're not supposed to have negatives under the radical, but when we do, no negatives under the radical. When we do, we factor it out. So this is the same as negative 1 times 16. The square root of negative 1 is the same thing as I. The square root of 16 is plus or minus 4. So this is 4I. And I'm just reminding you, this is plus or minus. For right now, I'm going to leave the plus or minus off and just simplify the radicals. But you do need to remember that they are plus or minus. Okay, 8. 8 is not a perfect square, so I need to break it apart into a perfect square that goes into it, which would be 4, and whatever's left. Remember, when you multiply radicals, you multiply what's under the radical. So 4 times 2 is 8. So this is the 8 broken apart. When you break it apart into two factors, one of them needs to be a perfect square because the whole reason you're breaking it apart is to solve the perfect square. Square root of 4 is 2. I can't simplify the square root of 2, so that stays square root of 2, and my answer is 2 square roots of 2. On the negative 8, it's going to be the same thing. I'm still going to have to break it apart, but I also have the negative under the radical. So the negative 1, and then the 8 gets broken apart to the square root of 4 times the square root of 2. And we know that the square root of negative 1 is I, the square root of 4 is 2, and the square root of 2 can't be simplified. And when we write this, we're going to write the coefficient in front of the I, so this is 2I square root of 2. Okay, when we have a fraction or a rational that's being divided, we can separate each of those. I would simplify if I can, but there's nothing that goes into 14 and 69. So, excuse me, 49 and 69. So I have negative 1 times the square root of 49 over the square root of 16. Since 49 and 16 are perfect squares, there's no reason to factor those apart. Square root of negative 1 is I, so I end up with I times 7. The square root of 16 is 4. But remember, the number goes in front of the imaginary number, so it's 7I over 4. And that's your answer. And remember, when you find square roots, these are all plus or minus. Go back and put those in there. These are all plus or minus. Okay, next one. See if you can simplify 27 and 25. And there's not anything goes into both 27 and 25. 27 is not a perfect square. I'm going to factor out the negative 1. And then 9 is a perfect square that goes into 27. So I'm going to break that apart to the square root of 9 times the square root of 3. And 25 is a perfect square, so I'm not going to separate that out. The negative 1 is an I. Square root of 9 is 3. And I have the square root of 3. And the square root of 25 is 5. And then I'm going to rewrite this as plus or minus 3I times the square root of 3 over 5. And that's how you would solve that one. Okay, so that's evaluating and simplifying square roots. Okay, we're going to continue to talk about imaginary numbers. And what I want you to do is treat the imaginary numbers like they are a variable, okay? And when you're looking at this, when we're adding and subtracting, we add like terms, just like you would with a variable. Okay, so I can combine the i's together and I can combine the whole numbers together. What you want to remember is that it's the format for imaginary numbers is the constant plus and then the number times I. The I term always comes last. So I'm going to combine the constants first. I have 4 and 6 is 10. And then I have a positive 6 and a negative 5, so that's a plus 1I. So my answer is 10 plus I. It's positive. Since I'm adding those two, I don't need to change signs. I can just combine like terms. Remember, though, that when we're subtracting two expressions, you've got to distribute that negative through the parentheses. That's like there's a negative 1 in front of the parentheses, so this becomes a negative 6. And this becomes a plus 2i, so I can combine like terms. On my constants, I have 4 and negative 6, so that's going to give me a negative 2. And then I have a negative 6i and a positive 2i, which is going to give me a minus 4i. And that's going to be my complex number. Remember, complex numbers, the I term always comes last. Okay, when we multiply, we're going to distribute here. Take the 6 times the 5, that's 30. When you multiply, you're going to multiply the constant with the coefficient. 5 times negative 3 is negative 15i. And that's your answer, just like as if they were variables. Where it starts to get tricky is when you're multiplying I terms together. And what we need to remember, we're still going to distribute, so I'm going to do that part first. 5i times 6 is 30i. 5i times 3i, multiply the constants. 5 times 3 is 15. I times I is I squared. And here's the thing, I squared always equals negative 1. So this is like 5 times negative 1. So this becomes 30i minus, because it's 5 times 1 is a negative 5, so minus 5. Make sure it doesn't look like a plus there. Minus 5. And then if I write it in the right format, in the standard form for a complex number, it's negative 5 plus 30i. Remember, the sign goes with whatever immediately follows it. And that would be your answer. So the key here is whenever you have I squared, you have to turn that I squared into a negative 1 and multiply it. Your answer should not have any exponents on your I term. If you have an exponent on your I term, then you haven't simplified it enough. All right, next one. These two parentheses are next to each other, so that means multiply. So we're going to FOIL. We're just going to multiply my first terms together. 5 times 6 is 30. I'm going to multiply my outside terms together. 5 times 2i. 5 times 2 is 10, so that's 10i. I'm going to multiply my inside terms. Let me see, that's an O. My inside terms. 3i, negative 3i times 6 is a minus 18i. And then I'm going to do my last terms. Negative 3i times a positive 2i. Negative 3 times positive 2 is a minus 6. I times I is I squared. Remember that the I squared is a negative 1. So this is negative 6 times negative 1. It means it's actually a plus 6. When I combine like terms, I have 30 and 6 is 36. 10i minus 18i is a negative 8i. And that's my final answer for that one. Okay. This is another FOIL. And what I want you to recognize here, what I hope you know, and if you don't, you do now. This is a conjugate. I suppose it helps if it's spelled right. Conjugate. There you go. And what that means, if you'll notice, they both have 6 and 2i in there. The only thing different is the signs are different. Those are conjugates of each other. You'll use conjugates whenever you're trying to get I out of a denominator. And we'll do some of those next. But a conjugate means it's the exact same numbers, but the signs are different. And the reason why it works, I'm going to show you here. When we multiply this and we FOIL, the 6 times 6 is 36. The outside is 6 times positive 2, which is a plus 12i. Now I'll get my inside in here. My inside is negative 2i times 6, that's a minus 12i. Those are my inside terms. And then my last terms are negative 2i and positive 2i. Negative 2 times 2 is a minus 4. I times I is I squared. And that's our last term. When we combine these, the 12i and the negative 12i are going to cancel each other out. The 4i squared, remember the I squared is like multiplying times a negative 1. So negative 4 times negative 1 becomes a plus 4. And I have 36 over here. 36 and 4 is 40. And the reason we use the conjugate to get the I out of the denominator when it is by doing these opposite signs, those I terms are going to cancel each other out. The I squared is going to become a constant, going to become a negative 1, and that helps us get rid of the I in the denominator. So we're going to use that now on 11. In order to get we want no i's, no imaginary numbers in our denominator. So to get rid of that, I'm going to multiply this times its conjugate, which is going to be the same terms, but at the opposite sign. And whatever I do on the bottom, I have to multiply the top by the same thing. When I multiply it on top, I'm distributing the 6. So 6 times 3 is 18. 6 times 2 is 12i. In the denominator, I'm foiling this. 3 times 3 is 9. 3 times 2i is a plus 6i. Negative 2i times 3 is a minus 6i. And negative 2i times positive 2i, negative 2 times 2 is a negative 4. I times I is I squared. Now remember that the 6 i's are going to cancel each other out. I squared is like multiplying by negative 1. So the negative 4 times negative 1, this becomes a plus 4. And I have the 9 over here. So that means on top I've got 18 plus 12i. On the bottom I have 9 plus 4, which is 13. And you could leave it like that, or some teachers will have you split it out into 2 parts so that you have 18 thirteenths plus 12i over 13ths. Break it into the constant and the I term. If you're one of my students, I'm Mrs. Reisinger. If you're one of my students, I would take it either way. Okay, but make sure you check with your teacher. Okay, 12, we're going to do one more with the conjugate. I'm trying to get rid of I in the denominator. So what I multiply by, same terms, 6 and I. Once, if this is plus, I'm going to multiply by the opposite sign. And whatever I multiply by on the bottom, I have to multiply the top by the same thing so that I don't change the value, because that's like multiplying by 1. And now I'm foiling both the top and the bottom. So on the top, I have 5 times 6 is 30. 5 times negative I is negative 5i. 4i times 6 is a positive 24i. 4i times negative I is a minus 4i squared. And then on the bottom, I'm going to FOIL the bottom. 6 times 6 is 36. 6 times minus I is a minus 6i. I times 6 is a plus 6i. And plus I times minus I, plus times a minus is a minus. I times I is I squared. Remember, our I squareds are like negative 1s. So negative 4 times negative 1, this becomes a plus 4. This is a negative times a negative 1, which becomes a plus 1. On the top, I have 30 plus 4 is 34. Negative 5i plus 24i is a plus 19i. And on the bottom, 36 plus 1 is 37. And the 6i and the 6i cancel each other out, so I'm left with that. You can leave, if you're with Mrs. Reiser, you can leave it like this. Some teachers are going to ask you to split it apart. So you have 34 37ths plus 19i over 37. And that'll work for that. And that's the end of that first section.